For chapter one, the thing that I really liked was learning about the different types of materials because I had never known that there were three types of materials previously. And I also thought learning about the tetrahedron was pretty cool. However, in chapter one, I didn't really feel like anything was particularly challenging because it was kind of like the introduction. So I don't think everything was like explained clearly and there wasn't really any room for confusion. In chapter 2, I really enjoyed learning about the electron configuration and atomic model. I remember previously learning that in like general chemistry for engineers. So since I already knew how to do it, it was very easy to understand. However, I kind of forgot how to do like the configuration part properly. So I would say that was probably the most difficult thing to kind of get a hang of, especially when you were combining to make compounds. I felt like that was a little bit difficult and I had gotten it wrong a few times before getting it right. In chapter 3, I really enjoyed learning about the crystalline structures, especially with the 3D examples that were brought into class. I feel like it made visualizing the actual difference very easy, and I think otherwise it would have been a little bit more difficult to understand. But one part of learning that I thought was difficult or kind of hard to get the hang of was calculating the unit edge length with the geometry. Um, I felt like I couldn't really visualize the arrangement of the atoms within the cell, and I feel like a more detailed or like a step-by-step would have been helpful because calculating the edge length was probably the worst out of the components of the crystalline structures. In chapter 4, my favorite part was calculating theoretical density and solving problems related to it. I felt that the problems were easy to understand and they were also like easy to visualize. It kind of really helped solidify the understanding of how atomic packing influences like material density. I would say the hardest part of chapter 4 was visualizing the defects, like the edge and screw dislocations, especially learning how everything relates, like dislocation motion, the Burgers vector, and how to draw the dislocation circuit. I think that was the part that I struggled with the most, especially drawing the vector for like Burgers vector on the physical uh, image of the dislocation. In chapter 5, I really enjoyed solving problems on non-steady state diffusion. Those questions were my favorite because they involved like very specific steps and it made them pretty like engaging to do, and I thought it was easy to understand. However, I think the worst part was the steady state diffusion. I thought it was a little bit more challenging to kind of grasp, and since I don't think we had as many examples in class as we did with non-steady state, I feel like more examples would have helped clarify it more. My favorite part of chapter 6 was learning about Hooke's law because of how easily applicable it was to like real life scenarios. I feel like the problems are interesting because you could really think about something that you've seen or a building or a bridge or anything that it really applied to, and it was really easy to understand what influences the difference in Hooke's law, like stress and strain. And I felt that ductility was probably the most challenging for me to understand, especially in relation to the stress strain plot. I couldn't really ever understand how to get ductility from looking at the plot or how it's like interpreted from the graph, so I feel like that could have been made a little bit clearer. In chapter 7, I really enjoyed doing the vector problems with the direction, especially the one with the ants that we had on our midterm. But I feel like it was really confusing to do directions and planes together in that one chapter because when I was learning about planes, I was confusing the rules for both a lot. And I felt like planes are pretty difficult to draw. Even once you got the hang of it, I feel like sometimes you can get a plane where it's kind of a confusing way. So I think that it's easy to confuse the two, and I feel like more examples emphasizing the difference in process to get both would have been more helpful. In chapter 8, my favorite part was solving the principle of fracture mechanics problems, especially the one involving specific surface energy. I thought those problems were cool because you could visualize what's happening like physically when you're doing the math for the problem, especially with the internal flaw versus surface flaw. but I still struggle with understanding how to interpret information from the SN curve. I don't think we did a lot of examples on it in class, and it was kind of briefly covered, so I feel like the relationship between the graph and the fatigue behavior of the material wasn't really that clear, and it was kind of hard to completely understand. In Chapter 9, my favorite part was drawing the microstructures. At first I thought it was pretty difficult to know like what to draw inside the circle, but once you kind of understand what's happening with the composition of the elements involved, I felt like it was a lot easier, and then you can answer like any type of questions once you understand one. The thing I had the most trouble with was the iron phase diagram because of how many components and details it had, and I feel like chapter 9 there was a lot of more information compared to other chapters, or a lot more graphs where you had to know the differences and like what to look for, so I feel like that was a bit challenging. My favorite chapter overall was chapter 6, which focused on stress, strain, and Hooke's law. I really enjoyed this chapter because of how much it blended material science with physics that I'm really passionate about. The application of Hooke's law to real-world problems made the material feel like more practical to learn, and the stress-strain relationship, the ability to calculate elastic deformation using the concepts were very straightforward and relatable, especially because of their connection to everyday materials that we all have seen, like springs. I really enjoyed like the problem-solving aspect when we calculated the stress, strain, safe factor, safety, and modulus values. It felt like more similar to physics, which is something I really enjoyed, and it really blended the two together. So that's why chapter 6 was my favorite. And then I think chapter 9, which dealt with the phase diagrams and microstructures, was the most challenging by far. I feel like the iron-carbon phase diagram was difficult to interpret because of its complexity and like the number of components. And there was like a lot of stuff that you had to kind of memorize or be able to understand by looking at it, even if you didn't fully memorize it. I think drawing microstructures required like a strong grasp of the graphical and like conceptual aspects of this chapter, which took a little bit of time to really understand. Even though I eventually understood the microstructures, the phase diagram itself felt less practical. Like I felt like it didn't really apply to anything, so it was a little bit harder to understand. I couldn't really apply it to like real life material like I could with stress and strain in chapter 6. So I felt like that's why it was a bit difficult. Um, Overall, my experience in the class was like incredible, especially as someone who's not Mechie. Like it was very refreshing to learn a different type of curriculum. I felt like the lectures were really engaging. Like the models were brought in for stuff that was a little bit more confusing or more 3D, and it was very helpful in aiding like understanding of certain topics. I felt like the lectures were really engaging and concise. Like there was only the material that we absolutely needed, and everything in the lecture slides was very easy to understand and very helpful to look back on when studying. I really appreciated like how much resources that we had to succeed in the class. I felt like it made it a lot more manageable and a lot more enjoyable because it was less stressful to be in this class because of all the stuff that was provided to us. I felt like everything was graded quickly and fairly, and I enjoyed the bonus points on the exams, and I felt like overall it was a very positive experience, and I would definitely take another Mechie course. Discussing the metal handles on the pans, I feel like the design modification to use metal handles could be appropriate if used with, in addition to something else like silicone handles or anything to prevent the heat from burning like our skin. I feel like something like maybe something hollow or heat resistant coating on the handle would be the only time this modification could be appropriate. I feel like a major advantage is probably that they're a lot more durable. Like unlike a plastic handle, the metal handles can resist damage from high temperatures and have like direct exposure to flames, use in ovens, so it could be like more versatile than having a pan with a plastic handle. But I feel like the biggest drawback is probably the high thermal conductivity. So without proper insulation or like consideration in design, they can become extremely hot during cooking and not really be useful at that point, because if you can't hold the handle, then it's kind of useless. So it could be a hazard, and it requires additional tools like oven mitts or a different design factor or element. So I think another item that I had never really thought twice about was like the lenses on my glasses. Now I really appreciate like the science behind them because most lenses are made from like polycarbonate, which is very lightweight and like durable enough to be used every day and be like kind of thrown around or scratched and stuff like that. I think it's really cool because material science like balances the properties that make up eyeglass lenses. And even though there's like OG lenses, which are glass and heavier, their scratch resistance and clarity make them more premium than polycarbonate. Um, Honestly, even more than that, what it was cooler to learn about was like the anti-reflective layers that you can get over the lenses, or like UV blocking, blue light blocking. Like there's a lot of modifications that require a lot of material science. Um, and you can kind of like tweak the eyeglass material to do exactly what you need it to do, just like you could add modifications on top of it. And the lenses are really like versatile. So every time I clean my lenses, I think about how much like material science has influenced the design of them now.